satellite communications in the new space era. Coming on to the introduction, since their inception, the satellite communication have found a large number of applications, including media broadcasting, backhauling, news gathering, and many more. Nowadays, following the evolution of internet-based applications, SatCom is going through a transformation phase, refocusing the system design on data services, namely broadband satellite communications. And the main motivation in this regard is the rapid adoption of media streaming instead of linear media broadcasting and the urgent need to extend broadband coverage to underserved areas. A major milestone of 5G communication system is the integration and convergence of wired and wireless technologies. In this context, satellite communication paved the way for seamless integration, taking advantage of their unique capabilities. The initiative New Space implies a new mentality towards space. It originated from three main aspects. First is the space privatization, satellite miniaturization, and novel services based on space data has resulted in a large number of broadband and Earth observation missions. The sequence of my presentation is as flashed on the screen. The origins of satellite communication can be traced to an article by Arthur C. Clarke in British radio magazine Wireless World in 1945, in which Clarke suggested a radio relay satellite in equatorial orbit with a period of 24 hours and that would remain stationary with respect to Earth. The satellite operation began in October 1957 with the launch of Sputnik 1 by USSR. The Sputnik 1 sparked space race between USA and USSR. It only carried beacon transmitter and no communication capability, but demonstrated that satellite could be launched in the orbit. The first successful launch by USA was Explorer 1, and after some delay, the first true communication satellites were Telstar 1 and Telstar 2, launched in 1962 and 1968 with the uplink of around 6,000 megahertz and a downlink of around 4,000 megahertz with a 50 megahertz of bandwidth. It carried solar cell batteries and single transponder and demonstrated live television link. It was launched in medium Earth orbit with 158 and 225 minutes of orbital period for these two satellites. Coming on to the system aspects. First is the constellation types. The three basic orbit configurations are low Earth orbit, medium Earth orbit, and geostationary Earth orbit, and the respective altitude ranges are given against each. Geostationary Earth satellites can cover about 1/3 of the Earth's surface, with the exception of polar regions, while the LEO and MEO orbits require more satellites to achieve such global coverage. Another relevant characteristic of satellite orbit is the eccentricity. Since circle has the eccentricity is equal to 0 and eccentricity increases with increasing elliptical shape, as shown in this figure. While for most of the satellite services, orbits are circular, there are cases of elliptical orbits with high eccentricity referred to as highly elliptical orbit. Examples include Molniya orbit and Tendra orbit. Such extremely elongated orbit have the advantage of long dwell time as shown in this figure. Coming on to the communication infrastructure, the basic structure of satellite communication system consists of space segment that includes satellite constellations, a ground segment including gateway station, ground facilities for control, network operations and backhauling, and a user segment with user terminal deployed on a fixed and mobile platforms, and the control of a satellite is performed by telemetry tracking and command station. The main task of these stations is to monitor the status of subsystems, run tests, and update the configurations. Such control mechanisms are needed for the maintenance purposes and in order to keep the satellite in the respective orbit. The link between the gateway station and the user terminal via intermediate satellite is the forward link. whereas the link coming from the user through the satellite to the gateway is referred to as the return link. The link connecting the gateway with the satellite in both directions is the feeder link or a feedback link, and the link connecting the satellite with the user terminal is referred to as user link. While link with the telemetry the link with the telemetry tracking and command station with the satellite is known as the control link. If we talk about the spectrum, the satellite communications operate in extremely high frequency band, in particularly between 1 to 50 gigahertz, and the low frequency spectrums are represented by these alphabets, while the higher frequencies are represented by these alphabets, and this spectrum diagram is represented in this slide. The radio navigation system like GPS and Galileo operate in L band, and S band is used for weather radar, surface ship radar, and some communication satellites, especially those of NASA, for communication with International Space Station. Satellite communications, especially TV broadcasting, operate in C and Ku band. To enhance the spectral efficiency, satellite systems have moved from single beam to multi-beam satellites with smaller beam spots. Due to spectrum scarcity, satellite operators are moving to K band, which offer much greater signal bandwidth. However, K band systems are more susceptible to adverse weather conditions. On the other hand, moving to higher frequency allow for smaller antenna size, thus promoting the use of multi-antenna system. If we talk about the air interface, first we will talk about the propagation effects. These are the phenomena that lead to signal loss on transmission through Earth's atmosphere. These include the atmospheric absorption due to different gases present in the atmosphere, then the cloud attenuations due to presence of ice particles, and the tropospheric scintillations due to the refractive effect, and Faraday rotations in the ionosphere, and the rain attenuation cause a largest attenuation for frequencies above 10 gigahertz, and it is the limiting factor in Ku and Ka band. Coming on to the antenna designs, in passive and focused reflective antennas, single feed per beam and multi-feed per beam architectures involve an array of feed horns at the focal plane of the reflectors. These are widely used architecture for geostationary Earth orbit systems. Whereas in active antennas, the amplifiers are integrated with radiating elements, and active antennas can be deployed in either direct radiating array or array fed reflector architectures. Whereas the antennas for ground terminal is also evolving area of technological development. Most recently, flat panel antennas with beam steering capability that enables the satellite on the move application are being developed. The onboard processing architecture, the figure represents a payload transporter employing digital processor. A standard analog front-end receiver processing includes antenna systems, analog beamforming network, low noise amplifier, down conversion, and automatic gain controller. Then we have a high-speed analog to digital conversion and baseband to IF conversion. Analysis filter bank for demultiplexing uplink signals, and synthesis filter bank to regenerate appropriate banks. Then we have a processing block that includes processing of individual streams like modulation and demodulation, coding and decoding, as well as a joint processing using MIMO technique. Whereas the switching block affects routing in spatial, temporal, and spectral domains. Now coming on to the application and use cases of satellite communications. The three major groups of 5G use cases are enhanced mobile broadband, massive machine type communication, and ultra reliable and low latency communication. In enhanced mobile broadband, backhauling and tower feed satellite provides a complementary role by backhauling the traffic load from the edge of the network. And in hybrid multiplayer, satellite ensures a direct 5G connectivity in remote area where our terrestrial infrastructure is difficult to implement. Whereas the communication on the move, satellite provides a direct or complementary connectivity to support 5G services on board moving platform. Whereas in massive machine type communication includes a wide area IoT services and a local area IoT services. In wide area IoT services covers the sectors of energy, transport, and agriculture, whereas the local area IoT services in it, their example include a smart grid subsystem for advanced metering and services to onboard moving platform. In ultra reliable and low latency communication to support services where the delay in the communication link is needed to be lower than 1 millisecond and reliability of around 1 packet loss per 10 packets is of utmost importance. Example include autonomous driving, remote surgery, and factory automations. Next use case is the aeronautical and maritime tracking and communication. Automatic dependent surveillance broadcast system is based on the capacity of aircraft to navigate to a destination, typically using global navigation satellite system data and barometer altitude, and to communicate to an air traffic controller and to participate in cooperative surveillance. It requires no human intervention. It is dependent on the data coming from the aircraft navigation system. Whereas the maritime automation identification system includes, it is used on ships as a tracking system. It provides the vessel information on identification and positioning on real time in order to avoid ship collision accidents. The next use case can be Earth observation and data collection. Earth observation has been used by government agencies to report weather, monitor oceans, detect changes in the vegetation, and analyze the damage done by the natural disasters, and many more. In the last few years, the space industry has experienced a trend toward investment in so-called agile space activity. The agile space sector is broadly split into two segments, the upstream and the downstream. The upstream is focusing on hardware, launchers, and rockets and satellites, whereas the downstream space data activities take information from the upstream and turn it into useful application for businesses. Now I will talk about the future of the satellite communication. In future of the satellite communication, the underway developments are digital twin for satellite systems, where these are the digital replicas of object, places, systems, people, and devices which can be utilized for various objectives and can act as the original item and spaces and peoples. Cooperative satellite swarms. These satellite swarm comprises of the small spacecraft consisting of an array of satellites which share the same mission. Then we have the onboard regeneration and flying base station. The use of onboard processing in satellite systems is paving way for realization of flying base station onboard a satellite. And the software-defined radio technology, in which a major part of functionality is implemented by means of software, which provides more flexible reactive platform. And thank you very much.